Hello and welcome back to my channel, Ontology Explained. I'm Casey Hart, philosopher and ontologist, and today we're going to talk about inference. I'm going to define it, test what its boundaries are, and discuss its role within artificial intelligence. There's no background knowledge required for this video, although I just released a video on introducing logic, and if you watch that one first, you might have a little better orientation to arguments, which come up a few times in just a few minutes. But before we dive into it, I want to back up a little bit and just say inference is not incredibly complicated. The implementation gets really hard. You could spend your entire life studying inference and how to implement it. But at its core, inference is something we do all the time, every day. Right? It's smoky outside, so I infer there must be a fire somewhere. You see copies of Kierkegaard on my bookshelf behind me, so you infer that I might have been interested in existentialism at one point or another in my life. I've got a MUFA, Madison Ultimate Frisbee Association shirt on, so you infer that I lived in Madison or live in Madison or played Ultimate Frisbee. Right? These are inferences that we can make. And what we're going to talk about later is just building on that core concept of inference. So I hope nobody's too intimidated. There's no level of academic qualification you really need to dive into this. Everybody can learn more about inference. So let's go. What is inference? The basic definition is just this. It's deriving new propositions from accepted ones. Or alternatively, we could say it's getting new information from existing data. This is a little bit different from arguments in the context of logic. So again, if you want to watch that other video, I'll drop it below in the description. But essentially, logic is the study of arguments. And arguments are sets of propositions where we have some premises and then one conclusion, and the premises are supposed to support the conclusion or lead to the conclusion in some way. Arguments are a little bit different than inference because inference is the process of moving from those premises to the conclusion. So it's the logical leap or jump. It's not the argument itself. Consider a calculator as an example. The calculation is essentially what inference is for arguments. So when I punch in 1 plus 3 and I hit the equals button and 4 shows up, the process that leads to the 4 coming up, that is the inference. Let's look at two classic examples, one for deductive inference and one for an inductive inference. So a deductive inference is something where the premises should guarantee the conclusion. And if you ever take a logic or philosophy course, you'll see this one. All men are mortal. Socrates is a man, so Socrates is immortal. That inference is the move from the two premises, all men are mortal and Socrates is a man, to the conclusion that Socrates is mortal. Beautiful. Then we have an inductive argument, something where the premises don't necessarily guarantee the truth of the conclusion. And for that, we can just consider a medical history or something. So if you looked at my medical charts, let's say, and you saw my blood pressure readings over the last 5 years, you would conclude that I have hypertension. That is an inference from a bunch of readings to some new proposition. Casey has hypertension. Also, just for the record, I realized this after one of my very first videos where I used an example of Casey has a doctor's appointment about cancer or something, and I had some friends message me. It was actually really lovely saying, "Oh, I'm sorry to hear about the diagnosis. I don't actually have cancer, nor do I think I have hypertension. It was just an example off the top of my head, so no worries." The move then, right, for these being inferences is just we're deriving something new. But what do I mean by a new proposition? Why does that matter? Well, let's consider the medical case again. Now we're just going to start stretching. We have two paradigm examples. Now we're going to try and stretch those and say okay, how far does this go? What are the edge cases where it's no longer an inference anymore? And one, which will still count as an inference, is suppose that also in my medical history, I had a diagnosis of hypertension. So you might think, looking at the blood pressure readings and then concluding that I have hypertension isn't really an inference because it's not a new claim. We already have within my historical data a diagnosis of hypertension. But in that case, the argument, or we're providing a new justification for the hypertension, right? We say, yes, we could look and see your diagnosis, but also here's another way that we could infer or justify the claim that you have hypertension, which is look at these blood pressure readings over the last X period of times, and they're over certain numbers, right? So it doesn't matter if you also have that piece of knowledge already somewhere in your data. An inference just means that we are able to go from some independent propositions to this claim. And even if we could prove that claim in a number of different ways, that doesn't undermine us calling it an inference. Why even have new as part of your definition of what an inference is? And that's because I don't think we want to count something like idempotent reasoning. So consider this argument. Casey is the most popular ontologist on YouTube. Therefore, Casey is the most popular ontologist on YouTube. That's not an inference in the way that we really want. We're just taking a claim and then we are reasserting that claim. It's an argument. It's a valid argument. I guess we can call it inference, but it doesn't really feel like the sort of thing that we want for inference. We want inference to be generating some new piece of knowledge or some knowledge that wasn't just a pulling out of something that was already in the set of premises. And if we take it back to the example of a calculator, right, what makes something a calculation? It's like a manipulation to generate something new. So if I entered a bunch of numbers into the calculator, right, I said 1579, and then I said return those numbers, and it said 1579, it doesn't feel like a computation has gone on. It was a storing and a recalling, but that's not a calculation. And similarly, I don't think we want these idempotent cases to be counting as inferences. Let's look at a slightly less trivial example, and that's with translation. Snow is white, therefore, Schnee ist weiß. Apologies for any bad German accent, but Schnee ist weiß just means snow is white in German. And again, I don't think we want to count this as an inference, even though the thing that shows up above as our premise is different from the thing in our conclusion. So why is that? And now we have to go back to another important part of the definition for what an inference is, that we're talking about propositions. So I've used these like sentences and propositions kind of loosely here or there, but in this case, it actually matters, the distinction between them. So every sentence, and that's just going to be like a natural language utterance. So something like Schnee ist weiß is a sentence, and snow is white is a sentence. And if you look at the transcript for this particular video, those will all be a bunch of sentences. But those sentences that you can say, snow is white and Schnee ist weiß, those both represent some core proposition, right? The reason that we say they mean the same thing is that they are both expressing the same proposition. And that proposition is the proposition that snow is white, where that proposition isn't understood in being any particular language. That is a complicated concept, but I hope you can get a little bit of what we're pointing to here. So when we claim that a inference is the generation of a new proposition, we mean it's not just reusing language or changing from one language to another. Instead, we mean that there has to be some new content, some new meaning that shows up in the conclusion that wasn't somewhere in our premises. So with that definition and understanding of what inference is on the table, let's think about how inference is treated in the industry of artificial intelligence. So if someone's pushing a product and they say, our product can do inference, what does that actually mean? The first answer is the person who's telling you that is a salesperson, and they probably don't know exactly what it means either. It's just kind of marketing speak, and we can more or less throw it away. But someone who's a little more serious when they're discussing what is the nature of inference probably doesn't see it as a binary thing. Instead, they're going to say there are something like 3 axes that we can evaluate the quality of an inference on. It's the strength of the inference, the novelty of the inference, and the complexity of the inference. So let's look at each of those in turn. The strength of an inference is just how likely is the conclusion to be true given that it was inferred. So a very strong inference engine or some AI that has very strong inference is one that you can really rely on the outputs of it. That's a pretty good thing. You might think, of course we want to rely on it, but often we are fine with tools that are right 90% of the time, 80% of the time, 70% of the time. So strength isn't everything. Contrast that with the novelty approach. So if we want to evaluate an inference based on novelty, we're thinking how interesting are the claims? How different are the claims from the premises? This would be if you looked at my office here, right? You might conclude that this person reads books, or this person likes baseball because you see a baseball on the shelf behind me. But a much more novel inference would be something like you look at it and you say this person has type O blood or something like that. Now, that seems less likely to be true. It's kind of hard to see, like, by looking at this scene, how would you infer that? But an inference engine or AI that produces inferences that are very unique, special, or surprising, that's some feathers in its cap. And you have to balance this, as you can see, between strength and novelty. I want to have reliable conclusions, but I want them to be reliable and interesting conclusions. So how can we have both of those things? That's a difficult balancing act, and not everyone can accomplish it. And then the third element about inference is the complexity. And this, since we're on my channel talking about ontologies and knowledge graphs all the time, when you think about the complexity of inference, if it's in a graph, you can think inference is just a traversal of the graph, right? So if I want to see that Christy is Casey's cousin, then we can follow Casey up to his parents, over to a sibling, and then down to one of their children, and that's what establishes the cousin relationship. And that piece of inference involves us going up, over, down, so 3 hops in the graph. But you can imagine some inferences are much shorter than that, right? The inference from Casey to his mother's maiden name is maybe a 2-hop inference, but you can have inferences that would jump 5 or 6 different directions through multiple different pathways. The more complicated the argument gets that's underlying the inference, the more complex it is, and that makes it a more powerful inference. So again, 3 things that we're looking for when we evaluate the nature of an inference. We're thinking, how strong is it? How likely is its conclusion to be true? How novel is the conclusion? Are you telling me something interesting? And how complicated is the inference? Also, when we're thinking about inference in the industry, you should think about reasoning. Reasoning is an important buzzword, but reasoning is a little bit different than inferencing, even though they're used interchangeably. So on its face, reasoning is a cognitive process that involves intentionality and strategically attempting to draw conclusions or successfully drawing those conclusions. And contrast that with inference, which is just a process by which we go from premises to conclusion. Why does this matter? Well, when you're branding something, you want to talk about it doing reasoning, because that makes it sound like your artificial intelligence has a mind. A recent example of talking about AI having reasoning comes from ChatGPT's the GPT-5 launch. And I'll go and just read a quote from this. I'll put a link to the video below. It's at about the 338 mark in that video. They said that reasoning is at the heart of our AGI program. Until now, our users have had to pick between the fast responses of a standard GPT or the slow, more thoughtful responses of our reasoning models. But GPT-5, it eliminates this choice. It aims to think just the perfect amount to give you the perfect answer. Now, I don't want to get too much into LLMs and GPT-5 and what's really going on here, although I think there's some interesting and important questions about whether LLMs can reason. My gut reaction to that is no, of course they can't reason. That's another video that's coming in the future, so stay tuned for that. But for now, all I want to emphasize is that it's very intentional that when they're marketing these LLMs and ChatGPT and GPT-5 in particular, that they're pushing reasoning over pushing inference, because reasoning has the connotation of a mind and thoughtfulness. It's important that it's not just a program to them that's generating useful output, but rather that it's a mind or an anthropomorphic entity that is reasoning and thinking. We just need to be careful that we're not taking along too much anthropomorphic baggage with it and implying cognition when it's not there, or at least not obviously there. And the last thing that I want to hit in this video is talking about inference as a property of systems rather than a property of an individual thing. So one mistake that people make is they say, oh, in this turtle file, turtle can't do inference. And that's true. I don't think there's obvious inference that shows up in turtle, but inference being a process means that it's just a function. We have some input and then we get output on the other side. That's our inference. And that machine that is doing the functioning can be a whole bunch of different things pieced together. And that's what we're going to see in some of the coming videos when we talk about ways to do inference for OWL RDF. So here are some of the options we could have. I mean, instead of just having a turtle file, we load that turtle file into a graph, and then we write queries against it, and those queries help generate the outputs that are essentially inferences. We have rules engines that you can augment your ontology with to sort of slap it on top of the ontology, run it, and then it will materialize some new triples, and that's a way of doing inference. We have out-of-the-box reasoners, as they're called, like Hermit and Elk, that we can use in Protege and other things to execute a form of reasoning over our triples and then generate new claims, right? That's a method of generating inferences. Or you could do all sorts of other coding things. So even though we're going to be looking as much as possible about reasoners and methods that are very semantic web oriented, there's nothing wrong with saying that I wrote some Python code that executes a SPARQL query, gets an output, and then does some, applies some rules to it and generates new claims. That can be a form of inference as well. So inference is a property of a system, and that system can be any number of pieces that are hooked together. Inferencing is one of the coolest things that you can do with OWL ontologies and in the semantic web in general, because our whole driving force is that we're using the meaning of these terms. And if you know what things mean, that allows you to leverage that understanding to conclude new things. So inference is really important, and that means we have to be able to build those systems that will generate those inferences. So let's summarize what we've covered so far in this video. Inference is the process of creating, generating, or justifying new propositions based on accepted ones. Or put another way, it's getting new information out of existing data. And we've considered a couple of core cases that all men are mortal, Socrates is a man, so Socrates is mortal. We've considered an inductive argument by looking at medical records. We looked at the importance of inference in artificial intelligence writ large, and that means, one, be wary of salespersons who are just using it as a buzzword, and also be wary of using reasoning to over anthropomorphize artificial intelligence. But if we want to evaluate an inference, we can evaluate it on 3 different axes. We can look at its strength, we can look at its novelty, and we can look at its complexity. Thanks so much for joining me for this video. I hope you'll stick around for some coming ones. Like and subscribe. We are going to do all sorts of things in ontology and philosophy, and specifically on the inference front, we are going to come up with some practical examples so you can see how to take your ontology that you've built and generate new and interesting findings from it. Thanks, and I'll see you next time.